points between a circle and a parabola. There are 5 possible cases of points of intersection between a circle and a parabola. We have the case 1 is we have no intersection at all. Case 2, 1 point of intersection. We have just 1 point of intersection. Case 3, we can have 2 points of intersections. Case 4, we have 3 points of intersection, and the last one, the fifth one, is 4 points of intersection. Just let's see individually with each case, but I'm taking one specific example, and I'm going to demonstrate how we can look at intersection with one specific example, but it can happen in general. For example, when we don't have intersection at all. As we see, the vertex is outside of the region or domain of the circle, like in this case when we have x squared plus y squared equal to 16, the formula for the circle, the equation for the circle, and the equation for the parabola is outside. So in this case here, we don't have any point of intersection between the parabola and the circle. Let's go to the case 2. Case 2, we have just 1 point of intersection. Especially in this case, for example, x squared plus y squared is 16, and x squared plus y is equal to x squared plus 4 for the parabola. And the vertex here is exactly on the circle, in 1 point of the circle. It can happen this way, or for example, if this is a y is equal to minus x squared minus 4, can happen and here, or can happen on the sides, just 1 point of the intersection. So we can have infinitely many cases when we have just 1 point of intersection. Even for example, when we don't have intersection, in the first case we have infinitely many cases, but I'm illustrated here just with one specific case. Case 3, we have the case when we have 2 intersections between parabola and the circle. For instance, if anywhere is here in this region somewhere, it can have just one, or can be, for example, parabola like this, in this form. One side can be outside, but one if we divide in a symmetric side of the parabola, one side of the parabola can intersect the 2 points of the circle. So even in this case we have infinitely, but as I said before, I am illustrating just with one example, and I think this example is enough to justify that when we have, for example, 2 points of intersection between a parabola and the circle. Now case 3, we have 3 points of intersection, and one of the case is this case when we have x squared plus y squared is 16, and y squared is equal to x squared minus 4. For example, here we have 1 point and those 2 points here, so there are 3 points of intersection. And now I'm going to illustrate the last example when we have 4 points of intersection. One of the example is here that is illustrated in the figure. Then we have x squared plus y squared is equal to 16, and we have a parabola y is equal to x squared minus 5.